Okay, welcome to Gazdonian Productions Studio, Sheet 15. This is physics, applied physics, Sheet 15. Here we go. First question. A mass undergoes a change in speed of 20 meters per second in 4 seconds. What is the acceleration of this mass? I'm going to write this on white paper here. So, one, let's write down the variables that we're looking for. Acceleration, that's what we're looking for. We'll put that as a question mark. We know the change in speed is 20 meters per second, so it tells you the change in speed. So delta V is 20 meters per second, and then the time is 4 seconds. We want to look on our reference table and see which of these we can use. We want acceleration and change of velocity and t, and it's this one right here. Okay, so I'm going to copy that down. Acceleration equals delta v over t, and I'm going to plug those numbers in. Let's see. So I'm trying to find acceleration. Delta v is 20 meters per second divided by 4 seconds. Okay. The numbers 20 divided by 4 is going to be 5. So our answer will be 5 acceleration. 5. But the units, let's do the keep change flip. So we're going to do that by, we're going to keep the top, and then we're going to change. So let me just do that on the side. So we're going to keep the top, meters over seconds, and then we're going to change the symbol to multiplication. We're going to flip that. That right there is s, or in this case s over 1. We're going to flip it to this. Okay? And then we have meter times 1 is meter. Second times second is second squared. That gives us the answer of meters per second squared, which makes sense for acceleration because that is the unit for acceleration. Meters per second squared. So that's pretty cool. That's the first one. Number two. How long will it take an object to move 100 meters if the object is traveling with the average speed of 0.5 meters per second? Okay, let's do this. So, let's see what we have. How long will it take? How long will it take? So, let's see what we're trying to solve for. So, hopefully you can realize that that's going to be time. Or time is what we want. Okay? Take an object to move that far. Okay, object to move 100 meters, that is your distance. Distance is 100 meters, and then average speed, average speed is 0.5 meters per second. And again, the speed is, you're just going to use that number. It's using average speed. That's cool. Where's the reference table? So, reference table. Looking at my variables that I have, which of these can I use? I need t, d, and delta v. Look at this one. Okay, so you look around and realize that that's what formulas have your variables in there. Let's do this. Delta v divided by equals delta v equals d divided by t. So I have my delta v. It is 0.5 meters over second equals the distance, which is 100 meters divided by time. Okay, so what you want to do is then you basically want to cross multiply, which is going to give you like this over 1. So this times this right here, and then 1 times 100 meters. That's going to give me 0.5 meters per second times t equals 100 meters. Now what I need to do is get t by itself, so I divide this by this, meters per second. And what I do to one side, I have to do to the other, 0.5 meters per second. So they cancel out here. It gives us t equals 100 meters divided by 0 meters over second. Keep change flip. I know you want to do it. Let's do that. So now I have so just because this math will be use your calculator. 100 divided by 0.5 is 200. Oftentimes people write 50. That's not right. It's not 100 times 0.5. It's 200. So it's going to be 200. And the units, what will the units be? Will be, let's do keep, change, flip. Keep my meters, change the division to multiplication, and flip this to seconds over meters. Okay, and then to successfully glurf it, I do this. And then meters over meter cancel out. Second over 1, my answer should be second, because it makes sense that time is in seconds. It does, therefore 200 seconds. Alright, please understand, goal, this is you to learn it. It's not just copying it down, not just copying out more formulas. So please do this with the right intentions. Okay, 3. An object is dropped from a cliff and it takes 8 seconds to hit the ground. How high is the cliff? The one thing you need to realize here is you need to, I know we wrote it down in class, acceleration due to gravity. When something's going to fall, it is 9.81 meters per second squared. That's the acceleration rate, and that's set. That's constant. So you need to recognize that that's on the reference table, and that's a number that we're going to need. So what I want to do is get another piece of paper here. And let's see. Object is dropped from a cliff. Sometimes it helps to like draw a picture. Here's a cliff. Object falling. I'm trying to find this. Right? I know the acceleration equals 9.81 meters per second squared. I'm trying to find this, which we're going to call distance. Okay, so these are all things you have to realize. Distance. We do know time is 8 seconds. So so we know acceleration is this, time is that. I'm trying to find distance. Now, you can, just with those 3, you can look here and say, do I have anything with acceleration and distance in it? And the answer, this does not have acceleration and distance. This doesn't either. This doesn't. It's either this one or this one. Okay? Alright, so what I need here is VI is the initial velocity, VF is final velocity, and I can't use this one because I don't know distance and I don't know the final velocity. So I need one that just kind of, I have most of the variables. Distance I'm trying to figure out. Initial velocity, I know because it starts out at the top of the cliff with no velocity. So initial velocity is 0, which is nice, it drops out. We know the acceleration, the uniform rate of acceleration for gravity, and we know the time. So that gives us, let me see, the formula here is going to be D equals VIT plus 1/2 AT squared. D I'm trying to solve. VI is 0 because it starts in this direction at rest. So that whole thing drops out, which is nice. 1/2 acceleration, 9.81 meters per second squared, times time, which is 8 seconds. 8 seconds, and that's squared. So what we get is D equals 1/2 9.81 meters per second squared. This is 64 seconds squared. Okay, and then we could just do the math. 1/2 times that is, and I do it like this. I do 0.5 times 9.81 times, nope, I messed that up. I do 0.5 times 9.81 times, what's it, 64? Is that. So the number 3.13, I don't think it says what to round to. My distance. And the units here, let's do the units. So now meters over seconds squared times seconds squared. Okay, they cancel each other out. The second squared successfully glurfed. The units will be meters, which makes sense. Does meters make sense for unit for distance? And it does. That's the answer right there. So that's a little more complicated, a little more to that. Okay, that was 3. Let's do 4. Let's do For a runner completes the 100-meter dash in 10 seconds, what is her average speed? Okay, this is a little more straightforward. Average speed. Let's see. So we have, what do we have? Average, we want to find this. Average speed is what? Time, 10 seconds. And then the distance is 100 meters. Now, if you look here, what's going to solve our, help us solve this? It's the first one. That's your average velocity. Sometimes it takes a while just to figure out that that's what you need. So the formula is average velocity equals d divided by t, which in this case will be, distance is 100 meters, 10 seconds. The units here, meters over seconds. This is where it comes from. If you can glurf, glurf. If you can't glurf, don't glurf. Because you can't cancel these at all. They don't, nothing sort of simplifies. So that just gives you your units. Okay, so it's going to give you the units will be meters over seconds. And then 100 divided by 10 is going to be 10. So the average velocity is 10 meters per second as they run this race. Okay? And then the last one, an object starting at rest accelerates at a rate of 3.0 meters per second squared for 6 seconds. What is the final velocity? Okay, so final velocity, what do I want? It is VF is what I'm looking for. It has the acceleration rate of 3.0 meters per second squared. Time is 6.0 seconds. And starting at rest, it gives me VI, which is 0, which is kind of nice. So which formula here will work based on what I have? And the answer is, I'm trying to find VF. So I want something with VF in it. This has VF in it, this has VF in it. But I can't use this, it doesn't have distance. But I do have time, I have acceleration, I have VI. So it's going to be that one, which is VF equals VI. I'm sorry, did I say it's going to be this one? I don't know if that's the one I just pointed to. Plus AT. I'm sorry. Yeah, distance. Yeah, so it's going to be the third one. I'm not sure if that's the one I pointed to, but it will be the third one. I don't have distance here. I can't use that one. So I'm trying to find VF is what I'm trying to find. VF, and VI is 0, which is nice, plus acceleration, which is 3.0 meters per second squared, times time, 6.0 seconds. Okay? So 3 times 6 is 18. Okay? And then the units here, I could do this. Seconds over 1. So meters over second squared. Notice this second cancels out with the second here, so I just cross out the squared. And it's going to give me meters per second. Final velocity of 18 meters per second. Does that make sense to me? Is velocity in meters per second? It is. And so that's sheet 15, first 5. This is the kind of stuff we'll be doing. Please do your best with this and understand this is stuff you need to know. Make sure you work through it. Watch this video a few times if you need to. But hopefully it helps. Thanks.